This is Unit 2, Day 3, and today we're going to learn about periodic trends and organize the elements according to the trends. The first one we're going to learn is one we've actually gone over before. It's called the octet rule. Each atom wants a total of 8 valence electrons, and our noble gases already have a full octet, which means that they're the least reactive. Other elements react to complete their octet, and here's how we identify these. Group 1 has 1 valence electron, Group 2 has 2 valence electrons, Group 13 has 3, 14 has 4, and so on. However, helium only has 2. And why is this? That's because its electron configuration is 1s2, meaning it's already full with the 2 electrons, whereas hydrogen only has 1, so it's 1s1. Therefore, it's not looking for another element to fill out its electron configuration because it's already full. Notice that the nonmetals are close to having 8 valence electrons. That means they tend to gain electrons to fill their octet. And metals tend to lose the valence electrons in their outermost energy level, which gives them a full octet in the energy level below. Sodium has 1s1, 2s2, 2p6, and 3s1. If it takes this one electron and gives it to somebody else, then that moves it down an energy level and it has a full p sublevel, so it makes it more stable. So how do we know which electrons are the valence ones? Electrons in your s and p sublevels in the outermost energy level are the valence electrons. Remember, you have 2 electrons to fill up your S level and 6 electrons to fill up your P level, which gives it 8 total. This is the reason why we have been having you draw your Lewis dot structures like this. We go 1, 2, 3, and down here's 4, 5, 6, 7, and 8. So it would go 1, 2, 3, 4, 5, 6, 7, and 8. And you've got a full octet. Alright, so let's practice. Notice this has only 3 electrons. So we can safely assume that this is in group 13 because group 13 only has 3 valence electrons. This one has 2, 4, 6, 7 electrons, which means it's group 17 because it's got 7 electrons. So then we can figure out the orbital notation for the alkaline earth metals. Your alkaline earth metals are your second group, which means that it only has 2 valence electrons, 1 and 2. So these periodic trends are ways we can distinguish differences in the elements on the periodic table. First, your atomic radius is going to be the distance between the atom's nucleus and its valence electrons. Basically, it shows the volume of the atom or how much space it'll take up. The atomic radius increases as you go down in the groups and to the left-hand side of the periodic table. So francium down here is your biggest element, whereas helium is your smallest. So here you can see most of your metals are very large, whereas your non-metals up here are very small. So the vertical pattern, as you move down the group, the atom's radius gets larger. And the reason is because as you are adding extra energy levels of electron, therefore making the atom bigger. The horizontal pattern is that atoms get larger as you move to the left across a period. All the elements in the same period have the same number of energy levels, but the number of protons in the nucleus changes. So you have 71 protons in neon, whereas you have 152 protons in lithium. Fewer protons means electrons are loosely held, therefore it's a big atom. More protons means electrons are tightly held, which makes it a small atom. Because neon, remember, doesn't want to give his electrons away, so he's holding them in real tight, whereas lithium doesn't mind sharing. So let's practice by putting these elements in order of increasing atomic radius. We can do this by counting the number of energy levels that they have. So strontium has 1, 2, 3, 4, and 5. Beryllium has 2. Calcium has 4, and magnesium has 3. So that means that beryllium is the smallest, and strontium is the largest. Calcium is next to that, and magnesium is in the middle. We'll go ahead and try this one. So silicon is in group 14, phosphorus is in group 15, aluminum is in 13, and sulfur is in 16. So if it increases this way across the periodic table, that means that the smaller groups have a larger size. So the smallest one would be sulfur, the largest one is aluminum, then comes silicon, then comes phosphorus. The next one is ionization energy, which is the amount of attraction an atom has for its own electrons. So remember, the smaller ones, like neon, compared to lithium, is holding on real tight to these electrons, whereas lithium wants to share, it wants anybody to take these electrons. Think of it as the energy required to remove an electron from the atom. A metal is happy to give away an electron. It doesn't take energy to do it. A nonmetal wants to gain electrons, not to lose them. So it would take a lot of energy to rip an electron away from a nonmetal. So you can see it increases going to the right side of the periodic table and going up a group. Therefore, helium has your highest ionization energy. You can remember that with a little phrase, IE equals HE. Ionization energy equals helium, which is your biggest one. Ionization energy increases as you go up the group because the electrons get closer to the nucleus. And it increases as you go to the right because there are more protons pulling on the electrons. So let's put these in order of increasing ionization energy. Remember, ionization heads towards helium. So take a look at your periodic table. You can see silicon is in group 14, tin is in 14, lead is in 14, and germanium is also in 14. So how would we distinguish its increasing ionization energy? We can't go from left to right, so we have to go from bottom up. So let's go ahead and label these by what period they're in. Silicon is in 3, tin is in 5, lead is in 6, and germanium is in 4. And if it gets smaller, the closer you get to the first group, that means that the sixth group has the least ionization energy. So let's put lead as the lowest, tin is next, germanium is after that, and silicon is after that. Let's practice with these ones too. These ones we can go ahead and order by their group number. So carbon is 14, nitrogen is 15, oxygen is 16, and boron is 13. And if it increases this way across the periodic table, that means that the higher your group number is, the more ionization energy it has. Oxygen is the highest, and boron is the lowest, putting carbon and nitrogen next. The last trend is electronegativity, which is the ability to attract electrons in a chemical bond. Think of it as the measure of how badly an atom wants an additional electron. Electronegativity increases towards fluorine. So it follows the same trend as ionization energy. But because the noble gases don't need an electron, we don't include it. Fluorine is our most electronegative element. It almost has 8 valence electrons and it really wants one more. So if you offer it one electron, it will take it away from you. Fluorine atoms will violently take electrons away from atoms around them, which makes it a very dangerous element to work with.
But the reason that fluorine makes such strong bonds is because it is a small atom and the nucleus is relatively highly charged because it's right on the right-hand side of the periodic table, but the electrons don't shield this nucleus. So it is very so-called electronegative. It attracts electrons to itself from other elements.
I've changed the prop now for some just normal barbecue briquettes. So this is pure carbon.
So we haven't done anything. This is cold charcoal and cold gas, and the gas just touching it is enough to start the fire. Think of that, just the cold gas setting things on fire. Most chemists are really too frightened to work with fluorine. You can't use it in glass vessels. It doesn't attack glass, but if the glass is a tiny bit wet, and most glass has moisture absorbed to it, then the fluorine forms hydrogen fluoride when it reacts with the water, and the hydrogen fluoride just eats through the glass.
Noble gases have virtually no electronegativity. This is because it has a full octet, so it's not looking for any more. It likes being by itself. So let's go ahead and practice by putting these elements in order of increasing electronegativity. You can go ahead and put these in order of their groups again. We're going to start with iron, which is be 8B. Cobalt, which is also 8B, but it's the second one in order. Tin, which is 18. Nickel is 8B, number 3, iron is number 1, and manganese, 7B. If you look on your periodic table, you can follow with me. Tin is the least. Remember, it basically doesn't want anything to do with ring elements. It goes manganese, iron, cobalt, nickel. We'll do this one as well. Sulfur is in group 16. Tellurium is in 16 as well. Selenium is also in 16. Neon is in 18. And oxygen is in 16 as well. So the ones that are all in 16 will have to order by their periods because it increases bottom up to right. Sulfur is in group 3. Tellurium is in group 5. Selenium is in group 4. And oxygen is in group 2. So first we know neon is the least. It's a noble gas. This is going to be tellurium, then selenium, sulfur, then oxygen.